Wonderful discussion about the max that explains why bell curve are everywhere. It is coming from Quanta Magazine. The Central Limit Theorem started as a bar trick for 18th century gambler. Now scientists rely on it every day. I just wanted to add a little bit extra bite here, and the nuggets is that whenever you're talking about Central Limit Theorem, so we are saying that you take more data, and typically 30 data is sound viable and really good, and then it also connect to the dot of something called empirical rule, right? So whenever you follow the normal distribution, if the data is normally distributed, that means -1 to +1 standard deviation is 68 percentage, and then you have a -2 to +2 is 95, -3 to +3 is 99.73, right? So that's what it talks about it. And also it says that the central limit theorem is what makes bell shaped distribution so ubiquitous. And then it talks about take an example of 100 people and guess that the jar, the beans of a jar, and it will also follow the normal distribution, that is bell curve, and you take the measure of the height of the men, women, all that, and various way we can use this one. And then there is a question that why does the bell curve pop up in so many data sets? The answer boiled down to the central limit theorem. Right? This is what it talks about it. It is now the pillar in the modern empirical science race, right? So that's what it talks about it. And there is a quote that I don't think the field of a statistic would exist without the central limit theorem, said Larry, statistician, right? And then there is a tiny story about purity from vice. So it talks about that in the 18th century in London, Abraham, mathematician talent were obvious. So many other peoples were there, and they have to pay the bill and all that. And Abraham made yearly mathematical investigation into game of chance. And of course, he also wrote a book that is coming up in the below slide. And flipping a coin, rolling a die, drawing a card, all these an example of probability, right? So flip coins 100 times, count how often the head comes up, right? So it will be somewhere around 50%, but not precisely, right? Sometimes you may get 40, 30, 70 and all that, right? And if you just play this game 10 times, you may get 10 different counts, right? And now imagine playing 1 million times. Of course, the bulk of outcome you will be close to 50. So the more and more you take, so you get more closer to mean value. And then it also talks about that, if you say that confidently, you can say that probability of getting 45 and 55 head is 68%. That's what -1 to +1 sigma. And then D Moire